Hi everybody, Cal here with section 14.5, the chain rule. You probably remember the chain rule from Calc 1, and it looks like this right here. If we have y as a function of x and x as a function of some other variable t, then dy dt is dy dx times dx dt. This is probably not the way that you're used to interfacing with the chain rule, but it is true. You should try out maybe an example from Calc 1 and see how it works in this language. With that in mind, we're going to talk about the chain rule in multivariable contexts. Now, what I'll say about this section is that this section is something where the theory is kind of a pain in the butt to write down, but it's really easy to use in practice. The value here is in the examples, and you want to spend a heck of a lot of time going over the examples in this section. So your book splits the chain rule into a whole bunch of cases, and I don't really hold with that. I would take these as examples of how the chain rule works, not really cases. But we're going to start here. Suppose that z is a function of x and y, where x and y both depend on t. Then z is a differentiable function of t, and dz dt is equal to df dx dx dt plus df dy dy dt. By the way, take a look. This looks awfully similar to what we were talking about in 14.4 with differentials, and that's not a mistake. These things are definitely related. You can ignore the proof. And we go to page 949, where they rewrite the chain rule like this in terms of z's instead of f's, and that's fine. Example 1 is really the money here. Take a look at how they deal with this example. They're just kind of substituting things into this chain rule formula. And in particular, they don't need to substitute in, when all is said and done, that x is equal to sine of 2t, y is equal to cosine of t in these expressions. They can just plug in t equals 0, the place they're interested in, into x and y and get the values for x and y. It's a lot less work. So pay careful attention to example 1. The blurb below it is still important. And example 2 is another really good example of just basic chain rule. So follow those examples pretty carefully. Now, below that, they talk about what if z is a function of x and y, but then x and y each depend on two variables, s and t. And they write a version of the chain rule for that. Make sure you understand what's saying here. It looks remarkably similar to what was happening when x and y were each functions of just one variable. Read the formula here, read example 3, and make sure you understand what's going on here. The blurb below example 3 is pretty good, and I especially like the part about tree diagrams. Your book probably doesn't spend enough real estate on this, but you can recover the entire chain rule by understanding these tree diagrams. And so as you do the next couple of examples, you're going to want to draw these diagrams and make sure you understand what's going on. On page 951, we have the general version of the chain rule, and really, for many of you, the way your book writes this is such a mess, you're going to want to kind of ignore this and just stick to tree diagrams. Example 4 and example 5 really demonstrate the different sorts of ways that this can play out, and I want you to spend a lot of time with these two examples. Make sure you understand the figures. Figure 3 goes with example 4, figure 4 goes with example 5. Make sure you understand what's going on there and how they're getting these chain rules, and how they're using it for specific functions in example 5. Example 6 is another good example, and I really like that one. You should work through it and make sure you understand why it works. And example 7 is pretty good as well. So these are all good things to work through. Then we get into a discussion of implicit differentiation, and the nice thing about the chain rule in its full form here is that it kind of lets us get a better look at implicit differentiation than we did earlier in this course and in Calc 1. Read through this derivation pretty carefully, and make sure you understand why this blurb works. Your book brings up the implicit function theorem and doesn't spend a lot of real estate on it. You don't have to worry about it too much. For those who go on and in mathematics, you're going to encounter the implicit function theorem. It's a pretty important thing. But for now, we can kind of ignore it. It's not that big of a deal. Example 8 shows you implicit differentiation in action using the chain rule. You'll notice that it's a lot easier to work with it this way than the old way. Example 9 shows this going on in 3 variables, which is where this really kind of has some value. It's a lot easier to do implicit differentiation this way with the chain rule than it was earlier. So make sure you understand what's going on in examples 8 and 9, and you're in pretty good shape.